Welcome everyone. Here we come to the last lecture of the week, which is on rebound effect. This actually deals with the issues regarding how a consumer behaves when a technology becomes more efficient, or especially a technology becomes more energy efficient. So to give you a little bit of introduction to the to the concept, that is when we talk about energy efficiency, when we introduce some energy efficient appliance or energy efficient equipment, we actually think about the technological potential that this particular type of equipment have to deliver in terms of energy efficiency. However, the human behavior may actually vary from this technological potential, and this is something we are going to explore in this video. I start with a simple example. This is a car I had. This is a big ambassador car with very low mileage. That is the kilometer that can be traveled with the help of 1 liter of petrol. So the mileage that was given by this old car was 8 kilometer per liter, very low. So I have decided to change my car, and now I have purchased a smaller car which is much more energy efficient, that is it gives a higher mileage, and I have replaced the big car. So this is the small car I have, and you can see that the mileage has gone up from 8 kilometer per liter to 16 kilometer per liter. So this is the energy efficiency. So you have replaced the non-energy efficient equipment by a more energy efficient equipment. Now what should ideally happen? What is the technological potential? What is the energy saving that is technically possible? What is the technological potential for energy saving? So what was my consumption behavior? Again, before I go to that, I would like you to take back to our discussion of the first week's first lecture discussion, where we discussed that there are three stages or three things that you have to decide when you are talking about energy consumption: the equipment that you use, the type of fuel that you use, and the level of use. So here we'll come back to that concept again and again. So in the previous case here, I have made a choice of the equipment. Now I have making some decision regarding the level of my use. So what is my use pattern with this car? I used to drive the car to my office twice a week because it was big and heavy, and it consumed a lot of petrol, and petrol is expensive. So I drove it twice a week, and my office is 10 kilometers away from my home. So, and I use it for some social visit. So for the office, I'm actually running my car for 40 kilometers, 20 kilometer per day, and I am using for the car I'm taking the car for social visits for another 40 kilometers. So my total use of the car was for 80 kilometers. So this is the initial situation. Now if my behavior, if my mobility habit or the habit of using my own car remains unchanged, then what is the result? What is the energy saving? See, the total petrol that I consumed with my old car was 80 liters, because with 1 liter I could drive for 8 kilometer, with 10 liter I can drive for 80 kilometer. This was the initial scenario. So this is 10 liter of petrol. Now with the new car, the mileage has doubled. So with 1 liter of petrol I can actually drive 2 kilometers instead of 1 kilometer. So what happens? I would need only 5 liters of petrol if I want to stick to my previous habit, if I am still running it for 80 kilometers. So my consumption comes down from 10 liter to 5 liter. So the energy saving potential of this new technology is 5 liter per week. This is what the technological potential of energy saving, this part. So my energy consumption should become half. Now the question is, this is how often a technologist look at the problem. But human mind, when you are thinking about as a consumer, your mind might work in a very different manner. When you replace a big car, energy non-efficient car, by a small energy efficient car, where the mileage goes up like anything, you will have a tendency to use this car more. You may no longer drive it for 80 kilometers, but you may end up driving it for 100 kilometers. Now the question is, what is the equation, what is the calculation that is going on in the mind of the consumer, which is different from what is going on in the mind of the technologist. And this interaction actually becomes very interesting. A consumer actually doesn't think about the way in which we have explained things. A consumer thinks, how much money am I paying for per kilometer travel that I am undertaking? So what is my expenditure for 1 kilometer? And there comes the role of price. You see, when you had the big car, your mileage was 8 km per liter. If you assume the petrol price is 60 rupees per liter, very optimistic though, but this is just an assumption. So if the petrol price is 60 rupees per liter, so you have to spend 60 rupees to drive 8 kilometers. Right? So you have to spend 60 rupees to buy 8 to go 8 kilometers. So the price that you are paying for your mobility service, that is price per kilometer, is 7.5 rupees. This is your price per kilometer. This is the price from where the consumer gets the signal. In the next case, when you are changing your car, what is happening? The mileage becomes 16 km per liter. As soon the mileage becomes 16 kilometers per liter, by spending the same 60 rupees, now you can drive more kilometers. Okay. So by spending 60 rupees, now you can drive 16 kilometers. So the price per kilometer comes down to 3.75 rupees. So as a consumer, if you think about the price of private mobility service, then you perceive the price as 7.5 rupees per kilometer, and here this is 3.75 rupees per kilometer. So the price of mobility service has gone down. As soon the price of mobility service goes down, as the law of demand holds, you will increase your mobility service. And that is why you may not end up running the car for 80 kilometers, you may end up running the car for more than 80 kilometers. As a result, what happens? What the consumer will exactly do, how much energy will exactly be saved, that cannot be understood before the use takes place. So it can go into different directions. So this was the initial situation that we had. The total kilometer travel was 80 kilometers and the petrol consumed was 10 kilometers. So this is the initial situation. The moment you change the car, there can be multiple things. There is no one direction in which the consumer's mind can work. It can go into multiple directions. And in the context of policy making, it's very important to understand this, the whole arena, all kind of directions in which it can go. So let us have a quick look at what are the different possibilities that can take place. The first thing that we called a no rebound scenario, the consumer, the level of consumption remains the same. So the whole technological potential of energy saving is realized here. So although the price per kilometer travel has come down, the consumer has not changed the behavior of travel. So the kilometer that you travel, that is not responsive to the price. So if you go back to the concept of price elasticity of demand, you can see in this scenario, in case of no rebound, the price elasticity of demand is 0. So although the price of some service is coming down, your demand has not changed. The change in demand due to change in price was the elasticity. So here the price is changing, but there is no change in demand. This is called the situation of no rebound. And if you have no rebound, then only the full technological potential of energy saving will be realized when some energy efficient equipment is introduced. The second situation, which is more plausible, is kind of a situation where you have partial rebound. So you thought that you would save 5 liters of petrol, but instead of that you end up saving only 3 liters of petrol. So your rebound is 2 liters of petrol. What is happening here? As soon you see that the price of per kilometer travel has come down, you increase your total travel from 80 kilometers to 112 kilometers. Now to run 112 kilometers, you need 7 liters of petrol. So what you have saved is 10 minus 7. So you are saving some energy, but this is not as per what was claimed by the technological change. Okay, so the realization is much lower as compared to what the technology promised. And this is happening because of the behavioral response. So sometimes what happens when we derive the models or when we do the projections, we say that if the technological progress takes a particular path, if this is the percentage of technological progress, then this is going to be the reduction in energy demand and hence this is going to be the reduction in CO2 emission. But it's very important to take into account that the behavioral response may dilute a part of this gain that we are thinking about. So this is the case of partial rebound. The third can be a full rebound. So it so happens the consumer feels like, okay, I just want to spend, this is a very common thing when you are thinking about petrol. So my psychology could be that I just keep 500 rupees aside in order to buy petrol. As many kilometers as I can drive with the petrol that I can purchase out of that 500 kilometer, I'll go for that. So this is a case of unique elasticity of demand. Your price elasticity of demand is 1. So if there is 1% fall in the price per kilometer traveled, your kilometer travel will go up by 1%. As a result, the expenditure on petrol will remain unchanged. As a result, your use of petrol will remain unchanged. So here you see from 80, it's actually increasing the kilometer travel to 160. So that still you are buying 10 liters of petrol. So although the technology promised saving of 5 liter of petrol, you end up saving nothing because your mind as a consumer is behaving in a very different manner. There can be some rosy scenarios as well, where this is not the rosy one, this is the most worst one. This is you can have some backfire. What is backfire? The consumer not only increases the consumption of petrol from 10, the consumption doesn't only stay at 10 liter of petrol, the consumption may as well increase. Because now you have an, kind of an energy efficient car, it's easy to drive, you know that per unit consumption, per unit expenditure is less. And if your, elasticity of demand, your price elasticity of demand is too reflexive, too flexible, then this 1% decline in price will actually lead to maybe 2-3% increase in use. As a result, your total expenditure on petrol is going to go up and your demand for petrol is also going to go up. So from 10 liter, instead of reducing anything, you are actually increasing your consumption to 14 liter. The rosy scenario that I was talking about could be a case of super conservation, where you expect the technology promises a saving of 5 liter of petrol, but the consumer actually ends up saving more than that. So it reduces. Now this kind of situation is very, very rare. It hardly has been documented in empirical studies. Where it is documented, it's mostly because of the fact that energy efficient appliances were introduced along with some awareness programs. So if some energy efficient lighting equipment were distributed, so it along with that the consumers were also told that this is the expected energy saving, and also they were told that, see, when you are going out of the room you better switch off the light. So the behavioral changes are so that not only you realize the technological gain, but your behavior is changed such a manner that you overshoot the technological gain. So but this is a very rare scenario. The question is which direction it finally goes. It's kind of uncertain. Unless the technology comes in the place, it's a bit difficult to understand which direction it's going to go. But you can have some clue. See this case of backfire. What is this happening? Initially I was driving for only 80 kilometers. Now I am driving 224 kilometers. When will that happen? This actually happens when you have a huge unsatiated demand. You have a lot of demand, but you are constrained by your resources, so you cannot meet your demand. In that case, where the price declines, you have a tendency to increase your demand to manifold. So the backfire is often observed in the context of developing countries, where you have a lot of unmet demand in place. The moment the technology comes, you actually tend to use it more. So think about a household where there was no electricity. Initially, when the electricity, it was introduced for few hours, you had some incandescent light. Then it was said that the electricity is being supplied for 24 hours and you have given the CFL. So two things are happening simultaneously. Because this is a very fundamental demand, this is a basic demand, the household will increase the use of electricity to get the lighting service to manifold. So whenever you have unmet demand, you can expect that technology, energy efficiency may not actually lead to reduction in energy use, but it can actually lead to a sustainable increase in energy use, which is also very important for sustainable development. If you recall the concept of load building, We said that for load management, it's not only conservation, but load building is also very important for load management. So this is a case where probably you are building the load through introduction of energy efficient technology. There is a large debate in this context that if energy efficiency comes into the place in the developing countries, because of rebound effect, a lot of potential gain is not achieved. But this takes us into some political debate as well. But one needs to understand that this happens, this kind of backfire happens because a certain section of household or certain section of population is denied to the basic, need for electricity or basic need for power. So this is a very important step towards sustainable development. We cannot look at it as if technology is being implemented and it's not being able to deliver what it is supposed to deliver. So this, if you can calculate the rebound effect, it gives you an understanding that what is going to be your future demand. So you should not underestimate your future demand, especially your country or your locality has a lot of unmet demand. In the final slide, what we are going to do, we are going to link the concept of rebound effect with the concept of own price elasticity. Now here I would like to mention this is only one way of looking at the problem. There are various ways how you can calculate the rebound effect. If you have very basic kind of the information that I have given for the car, if you have this kind of information at the household level, you can calculate the rebound effect at a very disaggregate level. You can take the help of energy, you can take the help of price elasticity in order to calculate the rebound effect. You can also take the help of a lot of modelings where certain parameters are used to understand the rebound effect. And the other thing is that rebound effect is not always equipment specific. So it may be sector specific. You can have a rebound effect for the whole economy. You may be interested in calculating that. So while your industry is becoming more energy efficient, probably you are saving a lot of energy and you are supplying that energy to the residential sector where the residential load building is taking place. So if you look at the economy wide, then shifting the energy consumption from one sector to other, that also reflects some kind of aggregate rebound effect. But here we are going to discuss only about the concept of own price elasticity. So coming back to our example, you see when we said that price per kilometer traveled had declined from 7.5 per kilometer to 3.75 kilometer, this is actually a 67% decline in the price of energy service. So notice I am not saying that this is a decline in the price of energy because the petrol price is not changing. What is changing is the price of energy service, right? So this is declining at a 67%. In case of super conservation, you see your price elasticity is actually positive. So this is contrary to the expectation of the economic theory. Your price elasticity, own price elasticity is positive. So 67% decline is leading to a decline in the demand for energy. In the second case, you see this is the case of no rebound. So even if the price declines by 67%, there is zero decline in the demand. This is leading to a price elasticity which is equal to 0 and therefore you have no rebound. In the third case, when you had partial rebound, this is the most plausible kind of a situation in most of the cases. Your price elasticity is negative, own price elasticity is negative. However, this is the absolute value is less than 1. So 67% increase in price has actually stipulated a decline in 67% decline in price has actually triggered 33% increase in your demand. So the increase in demand is less than the decrease in the price. In case of full rebound, as I said, this is like keeping 500 rupees. I have decided I'll spend this on petrol and I'll drive as many kilometers as I can. Here you see there is a 67% decline in price which is being matched by a 67% increase in the demand. So P declines at the rate of X, Q increases at the rate of X. As a result, P multiplied by Q, this remains constant. You can think about the shape of the demand curve here. How would the demand curve look like if you have full rebound? So this can be one exercise to think about. The final one, when we are talking about backfire, in case of backfire, a 67% decline in price has actually triggered a 95% increase in demand. So you can imagine that there's a whole lot of unmet demand that was present in this kind of a scenario, which has resulted in backfire. So in current literature, energy demand literature, rebound effect is one of the very important things to understand, especially in order to forecast the energy demand in the context of developing countries. But one should not think that this concept is very new and it has been perceived only in recent times. This has been discussed in the economic literature for many years. For example, this was the writing by Jabons in 1865 from the paper called Coal Question, and you can actually access this paper free of cost if you go to this site, where he's saying if the quantity of coal used in a blast furnace, for instance, be minimized in comparison with yield, so yield is the production, the profit of the trade will increase, new capital will be attracted, and price of pig iron will fall, but the demand for it will increase. So let us have a look at the phrase again. He is saying if the quantity of coal used in the blast furnace decreases, so there is energy efficiency, the amount of energy that you need to produce the same amount of pig iron, that reduces, right? You get energy efficiency, diminished comparison to yield. Then what happens? You are saving energy. You are saving on your energy bill. As a result, the cost of production comes down. So your profit goes up. The moment profit goes up, many people will be attracted towards this industry. So there will be more units being added to this industry. And eventually, the greater number of furnaces will more than to make up for the diminished consumption of each. So what is actually happening? There is energy efficiency. Each unit is saving on their energy bill. Therefore, there will be an increase in profit. The moment there is an increase in profit, more people will be attracted to produce pig iron. So the production will increase. The activity is going to increase. When the activity is going to increase, then your total demand for coal is going to increase. So initially you had 5 units who were producing. They become energy efficient. However, 5 more units are being added. So even if all the 10 units are energy efficient, the total coal consumption has gone up. So this is the concept of rebound effect. This was probably the first writing where the concept of rebound effect was first observed. After that, it has been taken different shapes and various methodologies has been devised how the rebound effect can be calculated. But this is a very important note where we are going to end our lecture on energy demand. If you have any questions, you can always post us. In the next week, we are going to move on to the issues regarding to energy supply. Thank you.